Hey guys, thanks for inviting Spartan Radar to this. My name is Blake Gasca. I lead the business unit at Spartan Radar. I'm one of the co-founders and chief revenue officer. I've spent the last 17 years in the automotive and transportation sensory space. More or less, last 5 to 7 years in the perception space in regards to level 4, level 5 autonomous vehicles. Obviously, the industry's faced quite a bit of challenges over the last, I would say, 3 to 5 years. However, there is progress being met. And really, the focus has really shifted from the overall stack to individual sensor modalities and their capabilities, which is why we're all here and why we're having this discussion. So when I look at the industry as it's evolved over the last 17 years of my career, starting my career in ultrasonic in a more of a self-parking assist system back in 2005 to 2007, I realized quickly how much AI and computer vision would take a toll in regards to how it would progress machine learning and AI forward. However, when I was approached a couple years ago by a guy on my team in San Diego who said, "Hey, look, I have a group of engineers that come from aerospace and they're on radar. They're on radar teams for weapons defense." And I said, "Radar? It's kind of the interesting modality out of the perception stack. I don't know much about it, to be honest with you, and I don't know many people that do. But tell me more." So when I had the opportunity to engage the other co-founders of Spartan Radar, I was immediately impressed with actually the capabilities of radar. And so my journey actually, while I come from the business side in autonomous vehicles, I became intrigued in regards to the possibilities if we could execute on a couple of the claims that were being thrown out there from the defense side. So I naturally went through I would say the evolution of Spartan Radar is what I'm going to share with you today, and kind of what we're trying to do here and what we have accomplished in our short history. But first and foremost, obviously, for me, in my simple mind, I wanted to really understand what the benefits of radar were versus the other modalities, which are a lot more documented, such as LiDAR and computer vision and even ultrasonic from a low range perspective. And obviously these are a given. Radar is not subject to environmental conditions as much as the other modalities. It provided the ability to work longer range. But one of the other challenges that I realized really early on with not knowing much about radar was how noisy it was. So how do you eliminate the noise that came from a radar versus kind of some of the other traditional perception modalities, right? So, and that really kind of brings into where the legacy traditional radars, in ways we all think, and this is really before digital imaging radars came to the forefront with heavy processing and more capabilities and relied on a central processing unit. But really poor resolution is to my point, was the challenging part that myself and others saw within this space, which was it was very noisy. It's primarily used as a fallback redundant sensor versus a primary sensor. And that was my understanding before, really joining a true radar team. The other challenges was the integration in the way that people were looking at radar. They were really taking a computer vision video regression model approach. Well, it's kind of paradoxical, right? It's garbage in, garbage out. If you're trying to run machine learning or building a classifier off of a very noisy data, your classifiers aren't going to be that good, right? So you needed some way to have higher resolution, be able to have that consistency, and we realized quickly that can only be done with software. And for us, it's all about, this is really the opportunity within this market, right? With radar, it is a lower cost sensor, and I say that it's all relative, right? It's a lower cost sensor versus LiDAR naturally. It doesn't have the capabilities from a computer vision standpoint with a camera has. And one of the things that we're really focusing on, what interests us, is really the contextual information that we could provide both in cab and externally without having to rely on heavy resources, both from a power and CPU standpoint, by just really focusing on the software. And when you talk about kind of where the industry is going and where it's going and where it's coming from, sensors as a whole, it seems like we're inundating the vehicle and people with sensors and specifically cameras and additional sensors. But in reality, the sensors need to do more. And the way we kind of look at this is it'd be very helpful as a vehicle were to be in a safety critical situation to understand where passengers or occupants within those vehicles are seated, as well as inbound or incoming rate of speed, as well as directional, the direction that the non-ego vehicle is approaching is important in regarding deploying safety critical technologies such as airbags and a couple other safety systems. And what I mean by that is, how often do you see an accident that you drive by and you realize that all the airbags are deployed and it's kind of a fender bender? So it's a lot of wasted resources on that. And how nice would it be to have the perception stack working in conjunction with the existing safety systems in cab to understand to deploy specific airbags in areas where we know that an occupant's at. Existing seat sensors and a few others are valuable, but they seem to be redundant. That's something that both camera and radar should already accomplish in cab, as well as, not just to mention, understanding the direction of where a vehicle is traveling. So again, nirvana, really where we see kind of everything kind of converging, is the ability to have the contextual awareness using kind of a passive sensor like radar. You know, it's kind of a challenge, right? One of the bigger challenges from a deployment standpoint to really reaching level 4 and level 5 really kind of comes down to commercialization, the cost. And so we're all aware of that. And really, to describe Spartan as a radar company is really unfair. At its core, we're a software company that specializes in DSP, signal processing. And the team comes from defense, which has great DNA around understanding specifically fighter jets and weapon systems using antiquated processing that's 10, 15, 20 years old and having to get more functionality out of it. When you don't have the luxury of using the latest and greatest, sensors like an NVIDIA Jetson, and you have these capabilities that have to be increased, right, in performance, you have to do that via software. And one of the things that we took from that world into kind of ADAS and automated vehicles is the ability to leverage existing sensor limitations. So that includes processing, power consumption, et cetera, mostly based on price point, and having those capabilities increase, right? So optimizing existing sensor capabilities at a lower price point. So the thought process, which our experience has always been, well, and there's plenty of people on the SOC side, really from the chip side, that have really said, well, throw more CPUs, throw more GPUs at the problem, and we'll get there. Well, it's kind of challenging and paradoxical when we're trying to use less power as we move more towards the EV. So that really can only be done, when we realize, is via software. And, as the increase in cost for the overall vehicle and specifically the perception stack, as need more GPUs and CPUs, which are shared among all the sensors, we realized if we can get more out of the existing legacy radar sensors, the better. Obviously everyone wins on this. They can allocate that saved resources either to affect their bottom line and profitability, and or leverage those CPUs into some other modality or safety unit, right? So it's a win-win for everyone. And we recognize that we don't look at ourselves as being an end-all solution. We recognize the other modalities are equally as important in order to make ADAS and safety systems get it to the next level. Not to mention, obviously, level 4, you're going to have camera, radar, LiDAR. But really what we're trying to do here is see how can we optimize performance in radar, which hasn't been seen before, versus discounting radar is, we're going to focus on computer vision and leverage LiDAR for ADAS purposes moving forward. Oh, and by the way, we'll look at a $150 to $200 digital imaging radar downstream for forward facing only. Forget like obstacle avoidance and 360. What we're basically saying is change that way of thinking. What happens when we are able to optimize existing legacy radar systems today that have the current process systems of today, and couple that with other perception modalities? And when you add all those up, we're pretty darn close to getting we're pretty darn close to getting to where the level where everyone wants to be from a safety critical standpoint. And for us, radar being good enough is relative, right? And what we figured out after having multiple discussions with existing tier ones and OEMs is, if you can supply something under 3 degrees, 2 degrees, a degree of angular resolution, you start crossing into LiDAR-like resolution territory, which is exactly what we're doing. Not with a digital image radar, we're actually doing this off more of an ARM architecture today at the edge, and we have these capabilities. But again, if we have the capabilities of working off of even digital imaging radar, we can even get better performance. And really what we're saying here is, if we can improve the overall existing legacy sensor systems that are out there, we then leave room to actually get closer and move the industry closer to that ADAS and level 4 that everyone's trying to achieve. And this is more on the business side. So this kind of brings me home to, okay, so Spartan Radar, you guys are a software company. You guys are more or less building your own radar system that is going out and giving better range, better resolution to solve level 4 challenges. The short answer is no. We do have our own capabilities. I always use the analogy, we're like the Google Play Edition or the Pixel version of Android, where we do have our own capabilities, which we are using in adjacent markets that are very focused on a specific niche or need. But our technology, specifically our software, is capable of impacting the industry today. And what that means is leveraging software for the existing hardware that's out there and getting better performance is something that we actually have done today. And like I said, this antiquated technology, especially in this day and age of chip shortages and budgets being cut and a few other things, actually helps Spartan in regards to, it gives us the ability where companies were saying, no, we're going to use brute force. We're going to pay more for better performance. Thanks, Spartan, but we don't really need that. Now they're opening up to saying we don't have that luxury. We're using kind of last year, a couple years ago, our SOC. What additional performance can you get out of this? Which is giving us the ability to show what we're made of, right? And by hitting these benchmarks over and over again and exceeding them, we're able to show people, hey, look it, you're fine here. You don't need to do anything else more from a hardware standpoint, or need to spend tens of millions, if not hundreds of millions of dollars in developing a new SOC. Leverage what you have today. When you have that new generation, we will be able to help and optimize that as well. Sorry, I'm going a little quick here, and I understand there's a time constraint. Sometimes I always say, hey, look at when I start talking, I'm too lazy to get stopped here. So I apologize if I'm going a little fast. But I'm really excited to talk about where we see the future of technology in general when we talk about sensor modalities going. And really from a radar standpoint, one of the things that's missed, that's commonly being adopted within the industry, specifically with computer vision, is the ability to have over-the-air updates. And being in automotive is great, but sometimes you can operate. Sometimes you have the looking through a single lens and facet kind of limits you what other industries are doing. And we're also can be found in agriculture, trucking, mining, vehicles. And one thing that's abundantly clear there, it's kind of install and leave it. And it needs to work for 10, 15, 20 years. Oh, and by the way, it needs to be relevant in 10, 15, 20 years from now. Very similar to defense, right? You build a fighter jet, the technology is built on there and baked. You may have several generations of the fighter jet. However, the hardware capabilities are pretty much dialed in. They're locked. But you have these ever-growing requirements of updated features that you need to bake on top of. That really can only be done if you have the capability of having over-the-air updates. So one thing that we really see here, and a couple of key players on the insurance side, as well as the transportation trucking side, came to us and said, look, we have some challenges here. We recognize that the safety features within the radar are valuable for the operator, valuable for the driver. However, we also need to have the ability to, because we're dealing with legal challenges and being sued by other vehicles that are on the road that may hit us, we have no way to protect ourselves. it'd be very helpful to turn that sensor that's very active into more of a passive awareness system that is giving us contextual awareness of oncoming vehicles as well as their speed and direction. And we want to be able to cache that information and be able to store it and to protect ourselves for claims data and a few other things. And that gave us the idea of saying, hey, what if we can actually provide that information and data and store it in a more of a telematics manner, that we can provide contextual data when there is an event or when there is something that occurs that you need to be able to offload that, similar to like a black box in an airplane. We know other modalities are doing it. You have telematics systems that have been doing it, that are taking the CAN data off and have been taking place for decades. What value would it be to actually provide radar data that would have non-bias and non-prejudice information about what's going on around the vehicle? And we took it a step further. We said, well, if we're connected and we have the ability to cache this information, offload it based on a triggered event, we can actually technically, since we're connected, we can actually update our software and also improve on debugging existing challenges, but also adding features downstream that would improve that radar over time. Similar to what you have in existing newer electric vehicle updates, software updates. The modality, the sensor modalities need to have the same train of thought, right? So for us, we are building a pipeline to keep the sensors current. And really, what does that mean? And not to mention, have a little bit of self-humility. Understand if something does go wrong, what place did we take within that, and what can we improve upon? And that really brings me to my next point. When you're talking about ADAS systems today, I understand a lot of us operate in a vacuum on the technology side, and specifically Silicon Valley companies, we're really holding our IP close. But when something does happen, it's important for the industry to be open about what data points can we share to help improve the industry as a whole. So from a holistic approach, it really makes sense to have the existing caching and over-the-air capabilities to really provide at least benchmarks, both internally within an organization that we can continue to perform on future products, but also what should be the industry standards, right? There's always this chicken and egg issue of, hey, here's what things should be, but we don't know if the technology's there yet. We're not willing to share our IP because that's our IP and that's our technological moat. So there's always this back and forth that we see consistently, but is there middle ground here? And again, this is a broader discussion. Is there middle ground where we can actually share information and data collectively as an industry and be able to perform benchmarks both internally and as an industry, which we can then have a starting point for state, federal, international law around what are the capabilities of existing sensor systems. This is a hot topic today with several automotive manufacturers out there kind of holding their ADAS automated self-driving capabilities to themselves. Totally appreciate that. It's a very sensitive discussion, but we need to start somewhere versus getting very selected reports which are selected by the OEMs as well as certain sensor systems, or just flat out not offered at all. And so for us, we want to be able to play within that space and be able to say, how can we build a product that is safe today, understanding that it's a moving target moving forward, where we can help contribute to safety benchmarks and contribute to with the way the industry should be, at the risk of really opening ourselves up to scrutiny should we not perform ourselves. And I think really this is a broader discussion that should be made to the industry. But in order to get there, we need to start building the piping and the framework and architecture today, which is exactly what we're doing. So while we believe that we're headed down the right path, we also are aware that we don't know where regulation and requirements are going to go, which is why we have to have not just an agnostic approach, but also an open approach of how we're going to perform in the future and where is that information going and what's made available to the public. With that said, overall the industry is growing. It's kind of been over the last couple months, the market's kind of taken a dip, and you start seeing the startup industry as well as the legacy players, the late stage startups, kind of go through their own individual challenges, probably a better way of saying it. But I look at it as it's a good time where we're not as distracted with, I would say, focusing on SPACing or going public and a few other things. I think everyone now needs to focus on their core competencies in technology. And what does that mean is really the companies that are going to be around the next 5, 10 years are focused and executing on what they have in front of them and determining, hey, is there a fit for their technology within that market? For us, we're looking at as a deep tech play at Spartan, doing some very challenging things with very deep industry knowledge that comes from multiple industries. We're looking to partner, right? And I think for us, we're looking to partner with other sensor modalities, tier ones, OEMs, to understand really what is the capabilities of the existing sensor stack out there today, but also where does the industry need to go? And I think for us, we're betting on software. We're betting on, hey, look at the end of the day, hardware is going to hit that wall, proverbial wall, and where if anything more, it's not going to be commercially viable. Or it's going to be very challenging to be commercially viable, but we need to have the performance that makes the vehicle safer. And it's a camera challenge, it's a LiDAR challenge, it's a radar challenge. And for us to really focus in on our small little corner of radar, which isn't small, right? Collectively with this conference, it's really the radar group. It's a collaborative effort. So for us, with our DSP knowledge, our capabilities of optimizing existing hardware, as well as contributing to hardware structure and framework, as well as antenna design, that's where we help what can be perceived as our competitors. We want to be able to partner and understand where we can help out. And then on the flip side of it, we do bring a level of expertise that can help augment existing teams, not replace existing teams. And then for us, the way we kind of see this is really focused in on, this is our individual aspirations and kind of where we see this going. So we talked a little bit about how collectively we see the world through the lens of software, but it's not limited to a certain use case. So we talked a lot about external facing radar sensing capabilities, and we talked a little about in-cab. We've talked a little about obstacle avoidance, but we do see room for improvement for all the modalities and all the use cases, specifically as it relates to obviously radar and safety. So our pipeline is really, we're heads down focused on building out the next generation ADAS radar system, leveraging our software. That includes our obstacle avoidance, which actually is focused in on, that is the building of our own hardware, as well as partnering with others within the trucking space. And that's more or less for big Class 8 vehicles, mining vehicles, agricultural vehicles that are a little bit further along in the automated space. And that's because they're not they're not running in very, I would say, complex ODDs like you would have on the automotive side. It's pretty much driving a straight line for a long period of time, or driving slow speeds in farmland. But nonetheless, they need to have updated modalities, and it's really important that we represent ourselves and help them out in that market. And then Spartan is quickly moving into the in-cab with the Euro NCAP mandate for occupancy monitoring, as well as that will be here for, I imagine NHTSA will bring that to North America here in the next couple years. We are focusing our super res algorithms and building on the capabilities for in-cab sensing. And then naturally, everyone in this space understands that in order to really tout yourself as a true player, the automotive ASPICE, the ASPICE certification is something that we're going to be achieving here over the next couple of years as well. And again, we do have aspirations to build our own sensor downstream, but we're having so much fun working and partnering with others that, for us, we see instant value of building alongside with some of the major tier ones out there today and SOC providers. So it's an exciting time. There's absolutely a lot of things for us to work on, and we're having to focus our attention on 2 or 3 verticals, candidly, rather than boil the ocean. So with that said, Spartan, I didn't really talk about the size of the organization, and I briefly talked about we've been around for roughly about 2 years now, but we're just under about 60 employees. We're based out of Southern California, but we have people all over the U.S. and growing internationally as well. And if you ever need to get a hold of us, feel free to reach out to us on our website, or you have the contact information on here. Great team, great people. Excited. It's exciting, but it's stressful because there's a lot going on to work with this team, as well as work with any one of you out there that is looking to partner. So thanks again.